In this tutorial, we're going to go over a basic introduction of MySQL, how to install MySQL Server, PHP-MyAdmin, and MySQL Workbench. We're going to teach you how to create databases and tables, how to import and export information from those tables, how to input, retrieve, and manipulate data with SQL, and some more advanced SQL techniques for those who want to get the most out of their system. Well, let's get started then. First, a quick aside about pronunciation. As you can tell, I've been calling it MySQL. That is the correct pronunciation. However, it is also commonly called MySQL. If you hear it called that, don't be confused. It's the same thing. So what is MySQL? Well, MySQL is a relational database management system, or RDBMS. According to a poll by Dell, around 90% of the 300 companies polled actively use these systems in their businesses. So as you can see, the RDBMSs play an important role for almost every company. MySQL is one of the most widely used of the RDBMSs in the world. According to the same poll, 41% of the companies were using MySQL, putting it in the top 3 along with Oracle and Microsoft SQL Server. So now that we know it's important, the next question is, just what is a relational database management system? Let's break it up into 2 parts. First, a database management system is simply a system designed to allow you to store and retrieve information from a database. For example, let's say you wanted to store a list of reservations. A database management system would allow you to put that information into a database, and it would store it for you and keep it available so that you could retrieve that data at any time. However, you can only pull out what you put in. Now, a relational database management system does the same thing, but it uses a particular structure for storing the data called the relational model. This model allows different pieces of information to connect to each other in a meaningful way. For example, if you look at the image on the right, you can see that there are 2 different sections of information. But despite these being stored separately, you can produce a combined section of the information. This is possible because both sets of information have something in common, the activity code. That commonality is what relates them. And storing the information with those commonalities is what makes the database relational. So how does MySQL store and retrieve data? It uses something called the client-server model. In this model, the database typically resides on a server and is accessed via a client through the internet. A client can be an interface for direct manipulation, such as PHP-MyAdmin, or it could even be a website, application, or program which operates behind the scenes. Now that we know what a client is, let's talk about how a client communicates with the server. To do this, it uses something called SQL, or Structured Query Language. This language can be used to define, update, and query the database. A query is just a term for the set of instructions sent. Like any language, SQL has a specific set of syntaxes that when sent from the client to the server can then be interpreted by MySQL so that it can take the appropriate action on the database. A quick example of this syntax would be something like select name from person where age equals 21. We'll get into the actual syntax later in the course, but for now, that's how it looks. And the best part is that SQL is used by virtually all relational database systems. So you can use the same set of instructions no matter what your environment is. That's it for the introduction. In the next video, we will go over the different types of data that can be stored within MySQL. Welcome back. In this lesson, we're going to be learning how to install some of the programs required to use MySQL, as well as some we're just going to be using in this lesson. The first 2 we're going to install are MySQL itself and PHP-MyAdmin. Fortunately, we can get both of these in a single package called XAMPP. If you go to the link provided, you will come to this page. Now we could sign in with Facebook or Google, but I choose to just use the alternative download, which will take you to this page. You'll quickly have a pop-up which will ask you to save a file. Click Save. We could watch their installation video, but I'll explain everything you need. Now, as you see, this is downloading. I'm going to cut a little bit out here to save some time. Now that it's all downloaded, we just have to open the file, and it'll ask us to run it. You may get a little pop-up that warns about possible slowing down of the installation due to an antivirus, but it doesn't really have much of an effect, so just click yes. Then you will click next. And in here, we don't really need most of these things. We're just looking for MySQL, so we're going to uncheck all of these. Remember, we also want to get PHP-MyAdmin. We're going to click next, and you can select the installation folder. By default, it's just C XAMPP. Don't have to click to learn anything more, so let's uncheck that. Now it's ready to install. Unpackaging. And once again, I'm going to cut to the end to save you some time. Once that's loaded, it'll take you to the finish page. And yes, we're going to go ahead and launch the control panel. It'll ask us to choose our language. And then you're going to see this easy to navigate panel. Let's go ahead and start Apache and MySQL. That's it. We actually have the prep work for a database already. And not only that, because we installed PHP-MyAdmin, we have a way to see it. To open PHP-MyAdmin, simply go back to your browser and type localhost PHP-MyAdmin. That'll bring you up to an interface where you can see that we now have MySQL installed and some test databases that come default on the system. We're not going to go into actually using this just yet, since this is just an installation video. We'll move on to the next thing. If you're not using Windows, then the installation instructions provided already may not tell you all you need to know. For XAMPP, if you're on a Mac, you can use the download location I provided in Figure 1. After downloading, just open the downloaded file. It should be named the same as I listed here. Drag and drop the XAMPP folder into your Applications folder. That should complete installation. And then, to start XAMPP, simply open the XAMPP control by going to /applications/XAMPP/XAMPP in your control finder. And from there, you can start Apache and MySQL. If you're on Linux, then you will need to use this location for download. After downloading, you're going to need to change your permissions on the file so that it can be executed. I provided the command to do that here in Figure 2a. After that, run the installer. The command for that is in 3a. Once it's running, you can just follow the prompts to install. It should be just like the Windows version. After installation, to start XAMPP, enter sudo /opt/lamp/lamp start. That'll load everything and should get you back where we were in the video. Speaking of videos, that's it for this one. We'll continue our installation with SQL Workbench in the next video. Next, we're going to install MySQL Workbench. It's similar to PHP-MyAdmin, but also has a few bells and whistles that we may want to utilize. Let's go to the download link, and you'll be taken to this page. Now, if you read carefully, you'll see that there are actually a couple of other things that need to be installed in order for MySQL Workbench to work. One of those is Visual C++, and the other is Microsoft.NET. I already have .NET, and you may too, but we're going to need to install this one. If you need both, the installation is the same. So let's click here. It'll take you to this page and ask to select the language. Next, it'll ask you whether you have a 64-bit computer or 32. Click 64 if you have that, which is what I do. Click Next. It's going to start your download. It's fairly small. So now that that's downloaded, we'll just click on the executable, click Run. It'll open up and ask you for you to agree, install, and it only takes a second, and now you have it installed. Simply close this. Let's go back to the original page, and now we're ready to install MySQL Workbench. It uses something called the MySQL installer, so we're going to go ahead and download that from its download page. If you scroll down a little further, it'll have two different options for you. Let's use the smaller one, as it doesn't download anything we don't need. Scroll down. You don't have to use or sign up anything. Just click No Thanks, Start My Download. Save file. It too is fairly small, so let's open it. You may get a small warning, but this is from Microsoft. It's harmless. Click OK, Run. It may ask if you want to upgrade. Just say no for now. I accept. Next. Now we only want part of this, so we're going to go to Custom, Next, Open Applications, MySQL Workbench, Continue Opening, and select MySQL Workbench. Now if you don't have all the necessary components, this will be grayed out and it'll tell you what you're missing. Just click over here once you're done, and click Next. That's it. Now we're ready to execute. And it's begun the installation. Once the installation is complete, just hit Next, and it'll ask if you want to launch. We will. And that's going to bring us to the setup. Now, to create a new connection, simply click the plus right here, and you'll see the connection window. First, let's give it a name. Let's call it Example Database. Next, we have the connection info. If you're connecting to a server, you may have to modify this a bit to connect to the right place, but for now, we're connecting to the instance we just made, which is local, so this is all already correct. Next, click OK, and now we actually have one set up. There may be a short warning, but it's just telling you that Workbench and the MySQL version we installed are different. It's no big deal. And now you've created the connection so that you can see the database that we created earlier. Now there's nothing in this database yet, but we'll go over that in our next video. For now, let's just talk about the differences in installation if you're not on a Windows machine. If you're on a Mac, you can get the same file we did earlier at the provided URL here. Once it's downloaded, double-click the downloaded file, and then drag MySQL Workbench icon onto the application folder. Once that's done, you can now launch the MySQL Workbench from the Applications folder, or from the command line. If you want to do it from the command line, the command is below. If you're on Linux, then you can get the download from Workbench by selecting your system from the Selected Operations System menu, but you can also get it automatically. All you have to do is type sudo apt-get update, hit enter. Quite a few things may load depending on what updates you need. Once that's done, type sudo apt-get MySQL Workbench, and it should install it for you. That's it. Now that we have all the tools installed, next time we'll go over how to create databases, tables, and columns. This has been brought to you by CreativeOnlineSchool.com. Welcome. In this lesson, we are going to go over data types. Specifically, what data types are, the most common data types, the data types that are supported by MySQL, how data types affect what you can do, and how to choose the best data types for you. So let's get started by going over what data types are. Data types are classifications for data that help to identify what kind of data is going to be stored, as well as how it will be used. What this means is that in effect, you can think of them as identifiers for the containers the data is going to be placed in. In fact, there is an easy comparison with something you are probably already familiar with. That's right. Just like the labels on these containers, data types determine what kind of information should be stored in the container. Also, just like these recycling containers, the data type labels aren't arbitrary. They matter because of what's going to be done with what's inside the container. If you put glass inside a paper container, then when it comes time to run the process, there are going to be problems. The same is true for data types. With that in mind, let's talk about what kinds of data types there are. Although there are dozens of different recognized data types, ranging from the common, like containers for numbers, to the obscure, like containers designed to store coordinates for locations in three-dimensional space, for now we're not going to be too concerned with the data types that are rarely used. We're going to focus on the data types that are most common, the ones you're actually likely to see. Those data types can be broken down into three broad categories. The first category is the numeric category. As the name suggests, these types deal with various kinds of numbers. The numerical types you are most likely to run into are integer, float, and decimal. The integer type primarily deals with whole numbers, while the floats can store numbers or numbers with decimals. However, it can round numbers and it truncates leading and trailing zeros. The decimal type is like the float type, but it stores the exact number without any rounding or truncating. The second category is called date time and relates to storing dates. The most common of these types are date, date time, and timestamp. Date stores only the date, usually in year, month, day format. Date time stores both the day and the time in hours, minutes, and seconds. Timestamp also stores the date and time, but it converts the time from its current time zone into the UTC time zone. And when you retrieve the information, it will automatically convert the time to the time zone of the requesting client. Finally, we have strings. Strings are one of the most versatile types because they can store all kinds of letters and characters, everything from a person's name to an account code that may have both letters and numbers together. The most commonly used string data types are char, varchar, and blob. These data types are a bit different from the others, as they all store the same types of information, but they store them in different ways. Char can store information of up to 255 characters in length, and it fills any remaining room with spaces, so it's always the same size. Next, we have varchar. Varchar, instead of having a set number of characters, is instead limited by the space that it is used by the data it's stored. It does not fill with spaces, so smaller strings take up less space. The maximum space used cannot exceed 65,535 bytes. Last, we have the blob. Blob data type, which stands for binary large object, can store up to 65,535 characters. However, it stores the text as binary data, ones and zeros, so it has to be converted back in order to be readable, and that requires more processing. Well, we've covered a lot of information so far, so let's pick up the rest of the lesson in the next video. Picking up where we left off, now that we know about data types, let's talk about how they relate to MySQL. MySQL supports all of the common data types and categories mentioned, as well as having specific categories for spatial types, and it has recently added the JSON data type, so it should cover almost any data type you're likely to have. Beyond that, it also allows for more efficient storage by supporting size-limited types. An example of this can be seen in the different scales for integers, which range from the tiny int with a max number of 255 all the way to a big int, which can store numbers of over 18 quintillion. This allows you to only allocate as much space as you will actually need. Now let's talk about how choosing a data type affects what you can do with the data. We have already mentioned several ways that the data type can affect the space used as well as your processing efficiency, but let's talk about something more tangible. That is, how the type affects what you can do with the data. For example, it is possible to store a date as an int or a string instead of as an actual date, and as long as all you are doing is storing and retrieving the date, that's fine. But let's say you then wanted to order the dates so that you had them from oldest to newest. Let's take a look at what happens in the chart below. When told to order the date, the system is going to order the integer by pure numeric value, while it orders the string alphabetically. Both of these fail to give you the date from oldest to newest, but the correct types allows for getting the correct dates in the right order. So now that we know how important the types can be, let's go over how to choose the best type for you. To do that, there are three primary things to consider. First, think about what you're going to be storing. That includes both what it is as well as its length. If all you're storing are small numbers, then there's no reason to use a string or a big int. That just limits functionality or wastes space. Also, consider how important it is to keep the data exactly as entered, or if it's okay for it to be converted in some way. Next, think about how you may want to organize or report on the data. If you're storing a name and a date, and you sometimes want it ordered alphabetically and sometimes you want it ordered by date, then you're going to need two separate data type containers. But if you know you will always need it in an alphabetical list with both name and date present, then it may be okay to store them together in a single string. Be careful though, as it may be too late if you decide later on you need them separate. Lastly, remember that this is a relational database, and as such, the data may be connecting to other data. It's always much easier to connect and filter data if both parts are the same type. Well, that's it for this lesson. Next time, we will go over how to install some of the programs you will need in order to use MySQL. Brought to you by CreativeOnlineSchool.com. Hello! In this lesson, we're going to go over the differences between PHP-MyAdmin and Workbench, how to create and update database, tables, and columns in both PHP-MyAdmin and Workbench. We're going to go over the principles of table design, as well as go over the uses of users and their permissions. We have already went over how to install both PHP-MyAdmin and MySQL Workbench, and later on we will be demonstrating how to do some basic tasks on both. But for now, let's talk about some of the core distinctions between the two. First of all, MySQL Workbench is a desktop software. This means that it is installed on your local operating system, and it can connect from there to different servers. This is helpful if you need to manage databases on multiple servers. PHP-MyAdmin, however, is a web-based tool, and is designed to be set up on the server itself. This means that it can be accessed through any browser and is not limited to a particular local device. This is helpful if you often use different devices or have multiple people working on the same server. Also, it's worth noting that PHP-MyAdmin is a bit more streamlined and is often easier to learn for new users. MySQL Workbench, on the other hand, contains some added functionalities like server administration and database modeling, which can be very useful when trying to visualize complex data relations. Okay, so now let's get started by showing how to create databases, tables, and columns. We will start with PHP-MyAdmin. Now remember, to open PHP-MyAdmin, just open a browser and type localhost/PHP-MyAdmin. If this was installed on a server that wasn't on your home machine, you could just put the server's address there instead of localhost. Next, to create a database, we simply go over here to the left and click New. Choose the database name. I want to call it Person, and then choose the collation type. Now, collation is a little bit of a tricky subject for people because there are a lot of options. But basically, collation just sets the language that your data is going to be interpreted in. And most people don't know the language that their data is going to be in, because a person's name, if input, could be in German, Spanish, or Chinese. So what we need is a good general way to sort through all of them. Fortunately, we have a good option, and it's what I use for most of my data. It's called UTF-8 MB4 Unicode CI. This uses Unicode formatting in order to sort things so it doesn't care what language it's in. And case insensitive just means it treats capitals and lower cases the same. So let's create our database. Now that we have a database, it's prompting us to create a table. You can set the number of columns and the name right here. Now every person has a name, so our first table we're going to call Name. And I'm only going to use 3 columns for this because we're going to keep it pretty simple. Now click Go, and it brings us into where we need to input the information. Remember those data types from earlier? This is where they come in handy. So our first column, I'm going to call it ID. It's always useful to have an ID because that way you can reference it in your other tables. And this ID is going to be very special. It's going to be our primary key. You select that here, primary. Now what this is going to do is it's going to say that this is the key thing that we're going to use to access other data types. So click Go. Now as an ID, we're going to want to increment it so that it's always unique. You don't want 2 IDs to be the same. AI just stands for auto increment. Next, every name has 2 parts, so we're going to call this one first name, and this one last name. We could do middle, but we're just keeping it simple. Next, we're going to change our type. There's no point trying to use an integer to be a name, so we're going to use the varchar. Now we have to set how many characters we want to use. A first name is not too likely to be over, say, 15 characters, so I'm going to put that. And the same for the last name. You could increment it if you think it'll be longer, but for now, this is what we'll use. Now, if we wanted, we can set default values. For first name, for example, we could choose, if no one inputs the name, to set the name as John. And for the last name, if no one inputs it, it'll say Doe. You could also default it to be null or default it to the current timestamp. Next, notice you could actually set your own collation for each variable, but we're just going to use the one that we set for the whole table. For attributes, it's going to change a little bit depending on your type, but the primary thing for integers is whether or not they're signed or unsigned. By default, they're signed, but that allows numbers to be both negative and positive. For an ID, we don't really need that, so we're going to choose unsigned. This also allows us to go up to the full number in the int range. If we wanted any of these to be null, we could select to allow them to be null. So let's click Save. And now, we not only have a database, but we have a table, and that table has 3 columns: ID, first name, and last name. That shows you how to do it in PHP-MyAdmin. In the next video, we'll go over how to do the same thing in MySQL Workbench. Now let's go over how to do the same thing in MySQL Workbench. First, choose your connection. If you have different databases, you can select them here, but we only have one for now. Remember, this is just a warning about a version difference. Over here, you can see that we already have the person database we created earlier. Now I'm going to create a new one by right-clicking and clicking Create Schema. Because this is a desktop application, it allows us to do things like right-click, which we couldn't in PHP-MyAdmin. We're going to give it a name. Since we already have person, we'll back up a step and we'll call this one Customers. Oops. Next, we'll choose the correlation type. We'll choose the same one, UTF-8, MB4, Unicode CI. Click Apply. Workbench does something interesting. It shows you the query that's going to be run before it runs it. This can be useful if you're trying to learn how they're working. Click Apply. It's executed, so now we hit Finish. And now you can see over here that we have a customer database. If I double click it, I can go up here and click Create New Table, and that'll give us our form. Now, I'm going to skip this for now because MySQL has the visual way to do this, which is one of the things that make it more unique, and it uses the same form, so we'll see it in a moment. For now, instead of this, we're going to click File, New Model, Add Diagram, and it's going to open up this page. From there, simply come over and press the table button, choose a place on the map, and now we've placed the table. If we double click it, we'll see that same form from earlier, and you can actually enter the table name and the columns at the same time. Since we already had person before, we'll name this one person. We'll give him an ID, which is an int. It's already selected that for us. We'll set it as the primary key and not null. And set its auto increment. Over here, we'll give each person a name, and it's selected barcode45 for us. We can change these things if we want. Each person, if they're a customer, is also going to have something they bought, so we'll say purchase. That should do for now. So if I get out of here, you can see that we have a representation of a table with 3 columns in it. Next, we're going to create one from a template. It has a few already loaded, and this will just save us some time. Now I'm going to go ahead and add a primary key since it doesn't have one. We'll call that person ID, since we're going to try to connect these in a moment. We'll set it as an int, primary key, non-null, and auto-incrementing. Now we have these 2 tables, and it can actually help us visually connect them. And the more tables you have, the easier it'll be to see how things connect if we do it this way. Also, it has a very handy feature of if you select down here and you select 2 tables, it'll automatically create a table that has the things they have in common in it. In this case, it has
the ID from person, and the person ID from user copy 1. These are called helper tables and can help you make your queries a little bit easier to use. Now that we have some tables, let's save them. You come over here to File, click Save Model. You can locate it anywhere you want. I'm just going to call this Model 1 for now. Click Save. Now that it's saved, we can come up here to Database, Forward Engineer. All this stuff will just stay the same. And it should be processing. Everything goes well, those are checked. We close it. And now, when we go back to look at our customers table, we can expand tables and see that we now have person, person has user, and user tables. All three of them were automatically created for us. And if we expand, we can see that inside there are columns for ID, name, and purchase. Well, that's how to make databases, tables, and columns in PHP MySQL. In the next video, we'll go over some principles on how to best structure your tables so they can be used together. Now that we have covered how to make tables, let's talk about some principles of table design. That is, some things you should think about when deciding which columns will go into which tables. The first and most fundamental is the idea of avoiding redundant data. Redundant data is what we call it when you're storing the same data multiple times or in multiple places. This wastes space and can lead to slowdown or even data inaccuracies if one gets updated and the other does not. Here's an example of redundant data. We are storing Dave's name, address, and email multiple times, which wastes space and makes keeping it up to date difficult. The second thing to think about is how the data will connect and include what's necessary to connect them. We call these keys. You already saw how we set an ID to be a primary key, and that's the primary way that data is going to be connected to other tables. So what does that look like? Well, let's try and fix our table here. First, to avoid redundant data, we keep info about the person in its own table with the primary key of ID. Next, we create the table for purchases. Notice the column on the right called Person ID. It stores the information needed to identify the correct person. We call these foreign keys, and it allows this data to be connected back to the primary key in the person table. Our last guideline is related to the other two, and that is that you need to think about what you're going to do with the data and how you're going to want to view it. This will help you to determine which tables need to connect to each other and which may be fine on their own. An important part of this process that we haven't currently covered is what happens when different people have different needs. This is handled through a combination of users and permissions. There are three main uses of users and permissions. First, it allows you to determine what actions a person can take on a database. You may not want everyone who can see the data also being able to enter new data or update it. The four primary permissions are read, write, update, and delete, and they allow a user to do exactly what you would expect. Next, you may want some people to be able to access some of your data, but not all of it. This is common, especially if you have sensitive information in some tables, but that's okay because permissions can be set per table, so you can choose to allow access only to what you want that user to have. And finally, a user can also be set so that they can only access information if they are making the connection from a specific place. So you could only allow access from your office, or only allow connections from other servers that you own. This greatly helps with security. Let's quickly go over how to create new users. First, select the database you want that user for. We did person over here, so I'll check that one. Go over here to privileges. That'll show you the users that currently have privileges. We can choose to add a new account. Select the username. I'll name mine Justin. A % means that you can connect from anywhere. If you have a specific location, you'll need to enter its IP. You can have a password, which you'd need to retype, but it'll also allow you to generate a random one for extra security, and we're going to do that. You can see that it's selected to grant privileges just for this table. If you wanted it everywhere, you could check here. Now, all of these here on the right are pretty much things you're only going to want your server administrator to have, but for generic users, you're only going to be using data permissions: select, insert, update, delete. File also helps if you have files that may be uploaded or downloaded. But we'll give this particular user select and update. Next, click Go, and that was created. I've now added a new user. So if we go back to person and go back to privileges, you can see the new user, Justin, has been added. For Workbench, to add a new user, all you have to do is select the table, go to Server, Users and Privileges, Add Account, select the name. You can see we've already used Justin from the one we added in PHP MyAdmin a moment ago. So for now, I'll just name it New Justin. We're going to leave it at %. It doesn't generate a password, so I'll have to make up one, and I'll use one that I choose to use, even though it thinks it's weak. It's only for a demonstration after all. We click Apply, and you can see New Justin has been added. Now, you can go over to Schema Privilege, choose to add an entry. You can choose whether you want this person to have access for all the databases or just a selected one. We're going to select Customers since that's the one we created here. Click OK, and then we can select our Select, Insert, Update, and Delete privileges that we normally have for our users. Click Apply, and there you have it. We have a new user with the permissions we want. Next time, we will go over importing and exporting data. This has been brought to you by CreativeOnlineSchool.com. Welcome! In this video, we're going to be talking about importing and exporting. That is, now that we know how to create tables and structure them, how do we get our data inside or out? Well, when we do that in bulk, it's called importing and exporting. Importing is taking data from an outside source and in a particular format and loading it into an existing table. Exporting is taking data that's already in a table and creating a file with that data in a specific format. The most common file formats are called CSV, XML, and JSON. CSV stands for comma separated value, and it's the most commonly used, and it's what we'll be using in this video. So let's get right to it. In PHP MyAdmin, all you have to do is select the table. Remember, we called this one Person, and its table's name was Name. Click Import. Select the file you want to import. We're going to click Name. Now inside of Name, this is what it looks like. You can see that it's encapsulated by quotes and separated by commas. This is pretty standard, and it has a different one on each line. If we scroll down, we can see that it shows us the same things. Columns separated with commas, columns enclosed with quotes. You can change these to be whatever you want, but you have to make sure it matches the file. Next, we're going to click Go. And now, if we go over to Browse, we'll see that there's actually data in our file. And that's importing data. So, to export it, we simply click Export. We don't have to select a template, but we do have to select a format. We'll do CSV again. There's also CSV for MS Excel if you intend to open it in an Excel sheet later. It can be useful. We're just doing it in text though, so CSV. Click Go. It'll automatically name it according to your table name. Click OK, and it's saved the file. It looks exactly like this one. Next, we're going to go over Workbench. In Workbench, we select Customers, because that's our table here, and Person was our table itself. Click this little square next to it, and that'll let you see what's in the table. Currently, it's empty. It also gives you your export and import buttons. We're going to click Import. I'm going to go to where I have the file. It's called Customers. Open. This is a preview of what it's going to look like, but it's not actually saved yet. We're going to click Apply. It'll show you your query, handy if you're trying to learn them. Click Apply. It's finished. And now you actually have the data in the table. To export, you click Export. And then you give it a name and click Save. We already have one called that, but we'll just replace it. And now we have it exported. Now, something to be aware of is this is what the table looks like when it's exported in CSV with Workbench. It's not all new lined. In fact, it's all in the same line, and there's also no quotes. These things aren't necessary. As long as they're separated by commas, it still works, as you saw when we imported it, but different programs can export in different ways, and there's no uniform method. Well, that's it for importing and exporting. Next time, we'll go over how to manipulate data with queries. Brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to go over an introduction to queries and query structure, cover some useful learning tools in PHP MyAdmin, as well as constructing some basic queries to select, insert, update, and delete data from our tables. First, let's start with what a query is. Queries are sets of instructions written in a language that can be understood by the database system. In our case, that system is MySQL. Queries have three basic parts: an action, a location, and a restriction. An action, or what the purpose of the query is, will begin with either select, insert, update, or delete. A location, which identifies which table or tables the action will be performed on, will be started by from and the table name. The restrictions, which is the most expansive section, covers what columns and rows of data will be affected. Most of them will start with where and the set of the restrictions. Restrictions often use operators like greater than, less than, equals, not equals, like, or not like. So let's quickly go over some of those tools I mentioned. If we select our database, you can see we already have some data in it from earlier. But up here, there are the search and insert tabs. Those will allow us to do things through a form instead of making a query. Now our goal is to make queries, but they can help us understand what's going on. So if I wanted to insert, I can say I want to insert Smith, and then just click Go. And you can see the insert it created. This is the format it follows. And now we're on the SQL tab, which is where you will write your own queries. And that brings us to the second thing that it has that's useful. It allows you to have default formats for deletes, updates, inserts, and selects. These tools can be very helpful when you're still getting used to the whole formatting of queries. But let's start making our own. For now, I'm going to use their preset format. This is a select. It's selecting ID, first name, and last name columns from the table name where1. Saying where1 is like saying where nothing. You don't even actually have to have this, but it uses it in the default. And I'll click Go, and you see it gives us all the things in the table. ID, first name, and last name, and everything in here. Now, we can edit in line to make things a little easier for us. And if I were to change ID, first name, and last name to star, I'll actually get the same thing because star means everything. That way you don't have to list them all out. So if I click Go, I get the same results. Next, let's go back and say where first name equals James. Now, because first name is a character set, we want to put the value in quotes. That identifies that we're talking about characters. If you don't put it in quotes, it's going to assume it's a number, and we'll probably get nothing in this case. So we click OK, and it gives us only the records who have a first name of James. If we wanted instead to use a number, we could say where
ID equals 1 or ID equals 4. Because these are numbers, we don't have to use those quotes. And an or means I'll accept it if either of these things are true. So I click go, and you see ID 1 James, but now we have ID 4 Amy. Next, we'll cover making more than one thing true. This one is either, but if we wanted two things to be true, we would change it to and the ID is never going to be the same number. So we're going to do first name again. You can also auto finish with this. Equals James. And remember when we just had James, we got 2 results. But because now we're also requiring the ID to equal 1, we only get 1 James. Next, let's change our search so that we only want the first name and last name. Let's say we didn't care about ID. I can change this to first name, comma, and when I run it this time, ID is no longer in the column. Next, let's, instead of using equals, use greater than. If I say where ID is greater than 1 and click go, you can see that it gives me 9 results. We're missing the first ID. I'm going to go ahead and put ID back in there just so that we can see what else is going on. Now, along with greater than, less than, and equals, there is not equals. So if I said where ID is not equal, that's an exclamation equal 4 or 5, I can click go, and you can see we've got all of them except ID 5. That's not equals. Last, we'll talk about likes. Likes are only used for strings. So let's do first name again. Like, open a quote. We're going to enter a percent. Percent is a wildcard character. It means anything before A, and that's just the letter A. And we're going to put another percent. So any A with anything before it or anything after it is acceptable. So I click go, and now I only get the names that have an A in them. And if you wanted only the ones without an A, you can just do not like. And that gives me the others. Now, there's one thing we haven't covered yet. We've been setting everything equal to or like something we're entering. But what happens if you're looking for a comparison of data you already have? So let's say where first name equals last name. And if we do that, then it'll actually look at everything in first name and find the ones that match it in last name. And if we click go, then we'll see Smith Smith, which we entered earlier. We'll be moving along now into the next video where we're going to do the rest of the updates, inserts, and deletes. Let's move along to the other kinds of queries. Next is insert. The primary difference between inserts and selects is that when you're selecting the table, instead of selecting from the table name, you're going to insert into the table name. The second thing is that there's 2 different formats you can follow. There's the one that they have here as their example, which lists the columns and then sets the values. If we were to enter values for these, and we're going to remove ID since that one auto increments, we don't actually want to assign any values there. And then we were to just replace these with Bobby Holmes. When we run this one, you can see
Bobby Holmes was inserted into our database, and the ID was auto increment. Now, the other format that you can use is insert into name, and instead of breaking them out into different sections, you can have set, which is a keyword, first name equal to Sandy, comma, last name equal to Meeks. And if we hit go, you can see that that also got inserted. Now, which format you use is entirely up to you. If there's only one or two values, it's often easier to use the second one. But when you're doing a big list of values, this one's much more efficient. Now we're going to move on to deletes. Deletes are one of the more interesting ones because they're very dangerous. As you can imagine, you don't want to lose your data. So it's much like a select. You delete from table and you have your where condition. Now, the reason they're dangerous is because if you don't do anything to this where condition, it's going to delete everything. So you have to be really careful what you're deleting. So it's often wise to actually run a select so that you can see the data before deleting it. So we're going to run a select, and we'll select star. And to do this as an example, we'll just say where ID equals 5. If we run this, then we can see which record we're going to delete, Sam Johnson. So I'm going to go back to the SQL, paste in the query we had, change select star to just delete. And when I run it, it will delete that record. You can see we no longer have an ID of 5 in here. Next we have updates. Updates use the format update, table name, and then it does set column equal, just like the second set of inserts we saw. So if I were to set, again, we don't have to do ID. Actually, we could do ID in this case because we're not inserting a value. Of course, we don't usually want to mess with those, but just to show you how it works, I'm going to set ID equal to 5, since I know there's not a 5 because we just deleted it. And then first name will be set to Billy, or Fully. Thompson. Now, again, your where is going to be important because you don't want to update everything. And if you ran this, it would update everything. So we have to insert our where, and we'll do where ID currently equals 10. We'll update that to 5, and that way we can see the change. And if I hit go and look at the data, you can see we now have a 5 of Bully Thompson, but we don't have a 10 because that one was updated. And that's how to do inserts, updates, and deletes. That's it for this video. Next time, we will begin discussing some more advanced concepts and query techniques. Brought to you by CreativeOnlineSchool.com. Before we go any further into more advanced queries, let's talk about something that will have an important effect on how those queries run: the database storage engine. In this lesson, we will go over what they are and talk about the most common ones and their differences. And then we will show you how to change the engines in both PHP-MyAdmin as well as in Workbench. In short, database storage engines are the things that power the queries that we run. Just like you have different engines in a sedan or a race car or a diesel, because of the different purposes of those vehicles, databases can have different storage engines depending on their best use case. There are 4 primary database storage engines: CSV, ISAM and MySAM, Heap,
or memory, and NODB. First, the CSV storage engine. CSV storage engine, as its name implies, has tables that are really text files with comma-separated values, just like the ones we were importing and exporting earlier. This allows the exchange of data with applications that can read and write to CSV format, but CSV tables are not indexed, and that can make them be extremely slow when running queries. They're mostly created just to assist with large imports and exports. The ISAM and MyISAM storage engines were designed with the idea that a database will be queried far more often than it will be updated. That is, based on the idea that selects will be what you'll run most of the time. As such, it's very fast when running those, but it can have some issues when you have frequent updates or inserts, especially ones run at the same time. This is because it doesn't support transactions. Each individual statement is run on its own, and they can sometimes overlap with each other if they're coming quickly. Also, it's not fault tolerant. What I mean by that is that if something goes wrong and your disk is corrupted or your hard drive fails, it's quite possible you'll lose everything. MyISAM is an upgraded version, and it allows for table locking and some better fault recovery to address those two issues, but it also requires periodic clearing of wasted space, and so is a little bit more labor intensive than the other options we have. Heap, or as it's recently been renamed, memory storage engines, allow for temporary tables that reside only in memory. They are faster than even ISAM or MyISAM. However, there is greater risk of data integrity issues because your data will be lost if it's not saved prior to shutdown. So if the power goes out or it locks up, you're going to lose a lot of your data. It's not really designed to be in long-term use. The last storage engine I'm going to talk about, and the one you may remember us selecting earlier in our databases, is called NODB. It was designed to address the ISAM and MyISAM issues with their transactions and their lack of foreign key support. This allows for better handling of parallel insert updates and deletes, so they're not likely to interfere with each other. However, it's slower than ISAM and MyISAM when it comes to doing select statements. As such, it can be very good for small to medium data operations, but if it's too large, it may need to be used in conjunction with MyISAM or memory, so that you can run the selects from there and then do the rest with NODB. Now that we know a little bit about the engines, let's go over how to change them. Here we are in PHPMyAdmin. All you have to do is click on your table, go over here to Operations, and you can see the drop down for Storage Engine. We currently have NODB selected, but you can choose CSV or MyISAM. Depending on the interface you're using, you may have different storage engine options. These are the ones we have for PHPMyAdmin. Next, we'll go to Workbench. To change it in here, once again go down to your table, just click this little wrench next to it. That'll open this window, and you can change the engine. You can see we have a few more options here. If I wanted to change it to MyISAM, I just click Apply, and you see the query, and now it's finished. They're very easy to change, and as such, you can use whatever engine you currently need. Well, that's all for storage engines. In the next video, we will go over some more complex queries, such as how to use multiple tables. Brought to you by CreativeOnlineSchool.com. Welcome! In this video, we're going to be going over joining, specifically what joining is, the different types of joins, some basic queries using joins. We'll then go over how to do multiple joins, as well as how to use the halving clause, which is used with joins. So what is joining? Well, joining is the process that allows data from multiple tables to be used. So far, we've only been running our queries on one table, but most of the time you're actually going to need to use two or even more. The four types of joins are inner, left, right, and full. An inner join, often just called a join, returns records that have matching values in both tables. It's the most common type of join and the one you're most likely to see. If you look at this picture, you can see that of the two tables, only the inner portion where they overlap is returned. A left outer join returns all records from the left table and the matched records from the right table. So if you look at this image, you can see that it will return the entire left table, but only the portion of the right table that matches the criteria. A right outer join returns all records from the right table and only the matched records from the left. As you can see here, it loads the whole right table, but only the matching records from the left. And a full outer join returns all records from both tables when there is a match in either the left or right. So it returns everything where either side has the value you're looking for. So let's get started on those queries. As you can see, I've created a few tables here. But for now, we're only going to be using the name and purchase tables. I've moved to Workbench because it allows us to see our results without clicking around quite as much. Our name table is just what you saw before, and the purchase table has some product names along with a name ID, which relates to the name.id, and the DOP, or date of purchase. So if we wanted to add the name to this list of results, we can simply say select star from purchase, join name, which is the other table we need, on, and this is where we specify how they're connected, name.id. Now, using the dot syntax simply helps you connect the name, the column and the table, because ID exists in both tables. If we don't specify this, it won't know which ID we're comparing to. So name.id equals name_ID. And if I execute this, you can see that it gives us our results. Notice that even though there's 15 names and even more purchases, we've only got the results where the name ID equals the name.id. That's what makes this an inner join. To make this a left join, we use the same syntax, but we change join to left join. When we execute this, you can see we've now added the row for peas. That's because there was a purchase for peas, but no name ID was recorded. So now we have all of the products, but we have null for the name because we couldn't match that record. To make this a right one, we change left to right. And when we execute it this time, we get all of the names, but it only has this many products to match. That's because there were no purchases made by these people. So everything else is null. Null just means empty. Now, if we change right to full, we're going to see that it actually gives us the same result as an inner join. That's because it's defaulting to an inner join because MySQL doesn't support the syntax for full joins. You have to achieve a full join by combining a right and left join. However, that requires a few things we haven't covered yet, so we'll have to push it off until later. That's it for this video. In the next one, we'll talk about doing more than one join, as well as the having clause. Picking up where we left off, we'll now discuss how to use more than one table. Now, according to the principles of table design we talked about, you'll remember that we really don't want to be storing the same data more than once. So I've changed our tables up a bit. Name is still the same. However, instead of using purchase like we did before, we're going to look at product, which now has the name of the product as well as a new column for distributor. And we have this other table called purchases that actually contains our date of purchase along with the IDs for the other two tables. So now we're going to need more than one join to connect them. If we start with the basic join we had before, with select star from purchases, join name on name.id equals name_ID. Then we simply do another join on product with product.id equal to product_. ID. And if we execute this, we'll see that it actually combines all three tables. It has the name as well as the product and the distributor. However, there's a couple of things that aren't ideal here. First, you can see that the column for your product name is just called name. This could easily be confused with a person's name. Also, when typing these, we're having to use our table names, and that can get long after a while. So we're going to solve both these issues by using something called aliases. To do that, we simply assign another value to the word that we're using. For example, purchases we can shorten to P. Name can be shortened to N. And product could be shortened to Pro, since we already have a P. And then instead of having name, we can just have N. Instead of having product, we can have Pro. And when we run it this time, we get the same result. Also, when we're doing our selects, instead of selecting all of these different IDs and a name that doesn't fit with our data, we can simply select what we want. So we can say name underscore ID, product underscore ID, DOP, first name, last name. Oops, that isn't capital. And then instead of using, we'll still select name, but instead of calling it name, we're going to say as product name underscore name. And we don't care about distributor right now either. So now when I execute, we're going to get a much cleaner list. Instead of name, it now says product name, so I can keep it clear. And I didn't have to retype the table names every time I was getting specific. In fact, if I wanted to add the IDs, I could even say p.id, n.id, and pro.id. And then I can add those IDs back in the select. And I could give them some names if I needed to keep them uniquely identifiable. So the aliases work both ways. But for now, we'll go back to our original information. From here, we're going to talk about the having clause. The having clause allows us to further filter our data now that we have it looking the way we want. To use the having clause, we'll go to the next line and simply type having. And let's say we only want them after a certain date. So we'll say DOP greater than, and we'll put it in quotes because it's not an integer, and we'll hit execute. And now we'll see that we only have the results that are further filtered by having a date later than the one we selected. Now this looks a lot like the where clause, and in fact you can even use them together, where last name like O and now we only have the ones that are after a later date and have an O in their last name. However, there is a few differences. The where is going to happen earlier on in the process than the having, and there's some things that can come in between. And we'll talk about those in a later video. Well, that's it for joins. In the next video, we will cover some of the things that you can do with the query results after you get them. Brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to be talking about the different ways to manipulate the data after you've retrieved it. Specifically, how to order your results, performing arithmetic on them, some string manipulations, and using the results you get as further query restrictions. So let's get in there. If we look at our purchases table, I've added a column for amounts, but other than that, it's the same. And currently we're looking at these results based on the order of the ID. That's the default because we're just selecting star, we're not giving it any further instructions.
But what if we wanted to order it by, say, the date of purchase? Well, to do that, we would go to the end and say order by DOP. Now, by default, it's going to order it in ascending order, or ASC. But as you can see, that orders it from oldest to newest. However, what if we wanted it the other way? Well, to do that, we would do DESC, or descending order. And that gives it to us from newest to oldest. It can do this because we've correctly labeled these as dates, so it knows how to order them. We're also not limited to only one order. As you can see, there's 2 orders on 910 and 2 orders on 810, and their product IDs are 13 and 94. Those aren't in any particular order. Well, what if we wanted them further ordered by product ID? We could simply add a comma and then do product ID descending. And now, not only are they ordered by date, which is first, but they're ordered by product ID in descending order. You can have as many of these as you wish. Now that we know how to order them, let's move on to a little bit of math. Let's say we wanted to do some calculations on these. Now I'll just be using mostly random numbers here for example, but you'll see what I'm talking about. So we're going to add amount to this result, but we're also then going to add 1 to it. So if I run this, we now have a new column, and it's calling itself amount plus 1 for now. We could name it with the as we saw in last video. But we now have this, which is amount plus 1. We can also subtract with a minus to have 1 less. We could multiply by 2. Multiplying in SQL is done with the star. That's going to give us a multiplied amount. Or we could divide. Dividing is done with the slash. And you can see we can even get results that have decimal places. That brings up another important point. What if you get a result that's not quite what's in the format you want? This one has decimals. Well, we can fix that. If we want to round down, we use the word floor. And then we encapsulate it. By doing this, it rounds everything down. And if we wanted to go up, we could use seal. And it rounds it up. So that shows us how to do numbers, but what if we wanted to deal with strings? Well, let's go over to our name table. We have the names first and last, just as we wanted it. But what if we wanted instead to have the names together as full name? Or what if we wanted the last name to be first? Well, instead of selecting star, we can select concat, short for concatenation. We open this up and we'll type last name, because that's what we want first, comma. We'll put an empty space here so that there's a space in between, and we'll enter another comma, and then we'll do first name, and we close it. So now when we run this, we're getting Donovan James as one field. Well, that's great for combining things, but what if you only wanted part of the name? Let's say we only wanted the first letter of the first name. Well, we can do that with a substring. In here, we can put substring, or substr. We'll open it up. We'll use the same name, but now we'll add a comma, and we have to select the positions that we want. Because we want the first letter, we're going to put 1, comma 1. This is from position 1 to position 1. And then we'll add another close. And when we run this, you'll see that we now have Donovan J, Patterson A. And if we wanted to go to 2, we would just change this to 2, or 3 in this case. And now we have the first 3 letters of the last name. That's how to manipulate characters. We'll continue on with how to use these things we're making to help further restrict our results in the next video. Let's pick up where we left off. We're going to talk about using some of those custom things we were making to further restrict our searches. Let's start with something simple. Name underscore ID plus product underscore ID. And we'll go ahead and also select star so that we can see the data. And we'll name this total just so that we can refer to it a little bit more easily. When we run this, we see our data, but we also see a total, which is product ID plus name ID. But what happens if we want to see the totals and only the ones greater than 10? Well, let's try it with a where clause. Where total greater than 10. It didn't work. That's because the where is looking for the information before it's created, because we're creating it as part of the select. But we have a solution for that. Remember how we discussed there was a timing difference between where and having? Well, if we use having, that takes place after the select, and so now we get the results we expect. Results of only those greater than 10. Now, as you can see, there are different product IDs, and there's different instances of, say, product ID 7. So what if we wanted to know the total amount of all of product 7's entries? Well, we can do that with a command called sum. Go over here and type sum amount. We'll leave it named total. And we'll have to set this equal to product ID equal 7. Otherwise, we'll get a total of everything in amount. So we'll execute this. Oh no, it didn't work again. Well, that's because having doesn't have access to the information that's not created from the data. So this one needs to be a where. The basic policy is that if it's in the data already, use a where. If it's something you're creating as part of the query, use have it. Now when we execute it, you'll see that the total for all of those amounts is 13. Now let's say instead of sum, you wanted to find the average of the numbers. You can simply change sum to average, or AVG. When we run this, you'll see the average of those numbers is 3.2500. We could floor it or seal it if we wanted to round it off, but we've already seen that. Next, let's move on to something a little different. What if we had data that we knew was supposed to be entered in a particular length, but may have been entered inaccurately? How would we find the correct ones? Well, we can do that with the length command. Let's say select length, first name, as total for naming purposes, and we'll also select star so that we can see exactly what we're linking. And remember, because we're creating this in the query, this is going to be a having command, having total equal to 5. If we run this, then we only get the results where there are exactly 5 characters in the first name field. This is very handy if you need to validate data of a particular length. That covers most of the basic things. In the next video, we will cover how to use these data manipulations more efficiently and how to get multiple results with grouping. This has been brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to talk about grouping. Specifically, grouping as it relates to data, how to use grouping to get a single result, how to use grouping to get multiple results, how to use grouping in combination with other query actions, like the math or string manipulations we've already covered. So, grouping as it relates to data. Grouping allows us to consolidate multiple rows of a result based on a common data value. That means if our original query produced 5 rows, but they're all for the same person, we can consolidate it down to 1 row. And that allows for the production of a result set that contains only the information that we care about. Well, let's see it in action. We're back in Workbench, And we've already got loaded up a query you've already seen. It's joining the name, product, and purchases tables. And in this case, we're doing it where name ID equals 1. That's the name for James Donovan, so that we can see all of the purchases that he's made. And he's made 3. But what if we only wanted to produce one result set? Maybe we're looking at a result that's going to be fed to a program that's going to insert his name into an email. Well, we don't want to get 3 results back because he only has one name. Well, to resolve this, we're going to do group by. And we're going to group by, in this case, first name. When we run this, notice that we only get one record. And if all you need is a consolidated report and based on first name, you're fine. But what if we wanted to go a step further? What if we wanted to see what his most recent purchase date was so that we can include that? Well, normally you do that by ordering. And if you order by DOP, descending, you would think that would give you the most recent date. However, it doesn't. That's because the order by happens before the group, and the group rearranges everything. So if we want the most recent date of purchase, we're going to have to do that in the select. We'll get rid of the order by for now. Here, we can select the max DOP, and we'll go ahead and name it max DOP. And when we run this, we've now got a new row. It's showing us the most recent of the dates for James. Well, let's take it even one more step further. What if we wanted to use some math on these functions? What if instead of just some random amount in the group, we wanted to know the total amount of all of his purchases? Well, we can do that too. In the select, we just add some amount. Because the group by is in effect, it knows what value set you're looking at, and so it will automatically sum them. And so we know the total is 18. He's bought 18 products, and his most recent purchase is on this date. You can see how this kind of stuff becomes more and more useful the more you add. We'll stop there for now and continue on with the rest in the next video. Picking up where we left off, we have a max date of purchase and the total amount of his purchases for James Donovan. So what if we're not just looking about James? What if we want to use everyone and find out their maxed date of purchase and how many products they purchased? Well, if we remove our where so that we're no longer caring specifically about him, we'll get that list. It's a list of one name and that name's max date of purchase and how many items they've bought. However, we've ran into an issue because we no longer have the ID requirement, and there were people with multiple first names that were the same in our database. That's why these numbers are so high. So instead of grouping by first name, we need to group by name.id, because that's a unique field. We'll know that we'll only have each person once, even if that person has the same name. When we run this, that looks better. Now we have the totals for every individual person that's in our database, even if they have the same name. And we could further refine it with our having clause. We could also say having a max DOP. We did rename that accidentally up here, but it's fine. Greater than 10. And now we've even further refined it so that we only have the most high purchase people in our list. But what if we wanted to add some more information? What if instead of looking for the highest people, we wanted to see the total that each person bought of each product? So let's get rid of that having for a moment, and we'll add another group by. We'll do that by simply adding a comma and now saying name, because name is the field that we have called the name of the product. Now when we run this, we'll see that we not only have the max data purchase for James Donovan, but we have two of them. That's because this is the max date when he bought flour, and this is the max date when he bought butter. And he's actually bought butter twice. That's why his max of butter is 15, but his amount is only 7, because one of the times he bought 7 and one of the times he bought 8. So this breaks it out even further. Now we have a list of the total of each product that every person has purchased, as well as the most recent time they've purchased that product. That's starting to sound like some real business data, isn't it? Now, one of the things that often comes up is if we're selecting their name and there may be other personal information like their address or phone number, how do we make sure that we get the most recent record? Since we're currently selecting what amounts to a random one of these in the group, how do we ensure that we get the most recent and up-to-date information? Well, we're going to have to add some more content. It's called subqueries. And subqueries are going to be what we cover in the next video, as well as the uses for the null value. This has been brought to you by CreativeOnlineSchool.com. Welcome. In this video, we're going to go over subqueries, specifically what they are, the benefits of using them. We're going to go over some examples of basic subqueries and their use, and we're going to go over using subqueries to pull the most recent records. Remember that thing we couldn't do in our joins? We're going to go over that here. Well, what is a subquery? A subquery, also sometimes called a nested query, is a query that is run inside of another query in order to return a row or set of rows of data for use in the primary query. What that means is that you can select data and use it almost as a new table to join in with your original query. The benefits of subqueries are they allow us to dynamically obtain information that we need, and they also allow us to get information in a way that may not be available at the processing state we need. Because of our group by, our order by didn't work earlier, but we can use subqueries to accomplish the same thing and get our recent dates. So let's go over an example of why we would need to use a subquery. You may remember this purchase table earlier. It contains our product info, but it doesn't have a product ID because it was never intended to connect to a product table. Well, if we wanted to use this info in our new queries, we wouldn't be able to connect them because of the lack of a key. However, with a subquery, we can find the appropriate product ID based on the product name. So let's do that. Here, instead of selecting from purchase, we're actually looking for the information that's in product. So we're going to select star from product, where product dot name, which was what we had the name of the product as, equals, and here's where we begin our subquery. Select product from purchase where ID equals 9. This will allow us to pull the information that we need based off the product name, because our product table, our purchase table, has the name of product, which is the same as the product.name. So when we run it, we see that P's, which exists in our purchase table, is actually product ID 5. And we could use that information to join it back in with the rest of the data. So that's fine if we know the ID or only want to pull one record. But what if we wanted to find all of the products that match our name that we have in the purchase table? Well, one way to do that with subqueries is to use right join. That will allow us to join all of the results of the query in with the main query. Let's show that now. We'll still be selecting star from product, but now it will be right joined, and we'll start our query. Select purchase.id as PID. It's good to give things like ID that are very vague different names when you're using subqueries so that you can reference them later and so you don't get confused. From purchase. And now we're actually going to do a join in the subquery. From purchase, join product on product equals name. Now we're going to give the result of this a name so that we can use it as a table. For now, we'll just call it A. And we'll say as A, just so that we have some more things here. Now this happens just like a table would. So we're still in the middle of our join. We now have to say what we're joining on. So we say on product.id equals PID. And that will allow us to join product to the results of this query. And if we run this, we can now get the product ID of every name that matches something in our purchase table. So we can now use it even though it doesn't have a key. We'll continue on with these in our next video.
Picking up where we left off, we're still talking about subqueries, and now we're going to use them to accomplish something we couldn't accomplish earlier. You may remember this query, where we used our double joins to produce a max data purchase and to sum the amounts by product type. But we weren't able to obtain the most recent data, so if we had phone number or email address, something we needed to keep up to date, this wouldn't be as useful as we needed it to be. Well, we're going to fix that with a subquery. In this case, instead of typing it, I'm going to paste it in just to save us some time, and then I'll explain it. We're going to take that same query, and we're simply throwing in this inner join right here. Now, an inner join is the same thing as a join. I'm just labeling it so that it can be visibly different. And within that join, we have this select statement. We're now selecting the max data purchase, and we're calling it last date. We're also selecting the name ID and the sum of the amounts of the totals. We're doing that from purchases, and then we're going to group by name and product ID. It looks a lot like what we were doing on the outside, but now we're doing it on the inside, and we're calling it submax, the subquery max values. Because we're doing it within the subquery now, we no longer need to select these in our external query. And we're going to join the results that we get from this query on purchase data purchase equals submax.latest date. So what that means is we're pulling out the data purchase just like we were before, but now we're only selecting from the table where that data purchase equals the max data purchase. That's giving us our most recent record. So when I run this, you can see that not only do we have our totals, and we have latest date here so we can use a comparison, but our latest date is also the date we're selecting with our other data. And you can see the product IDs and amounts have changed a little bit. That's because it's now showing the most recent record. This is a very common thing that you're going to need to do in your data because usually the most recent record is the one that's going to be the most important. Let's pop back over and talk about something we've seen a few times but never really went in depth on, and that's null values. Null is a representation of an empty piece of data. It means there's nothing there. However, because there's nothing there, null is not actually a value, and so it cannot be compared with a value operator such as equals. If you try to check if a column equals null, you're not going to get any results. However, because of this, null values have their own operators, and that is null or is not null. Let's see this really quick. We're back in our purchase table because you may remember we had a name ID that was null. Somehow this got entered for a purchase, but we don't know who it was that purchased it. And it's the perfect example for us. If we were looking for all the information in our data that didn't have a value, we might try to say where name ID equals null, because that's what we see represented in the table. But if we try to run this, we're not going to get anything out of it. It just gives us a bunch of empty values. The same thing happens if you try to say equals an empty string or 0. We're not actually getting the table place where the value is null. And that's because we need to use the command isNull. If we do that, then we get our product, P's, and we can see that it's missing the information. This is useful when trying to find information that needs updating. You can also use isNotNull in case you wanted to obtain all the information where you had all the pieces of data. And in this case, we no longer include P's in our list. We have only those that have all of the data we entered. That's enough for this video. In the next and final lesson, we will cover transactions and sequences. This has been brought to you by CreativeOnlineSchool.com. Hello, and welcome to the last video in this lesson. In this video, we're going to cover sequences and transactions. A sequence is a set of integers, such as 1, 2, 3, that are generated in order on a specific demand. We already saw an example of sequences when we set our IDs to auto-increment in our tables. They go up by 1 automatically. That is, in fact, the most common type of sequence. A transaction is a set of queries that must all be completed before the action becomes permanent. One of the things that transactions is necessary for are things like auto-incrementing. The correct ID has to be determined, and then the insert has to happen. And we need to make sure that nothing happens in between, and so we can use a transaction. Transactions begin with start transaction command and end with commit if the transaction was successful, or roll back if not. It will undo everything that happened within the transaction. Let's see an example. Here we have our name table. Now, if we look at the actual table itself, we can see where we set the auto increment, and that's where we've been doing our sequence. But if we remove this and wanted to do it ourselves, I'm going to click apply. Now it's no longer going to auto increment. Instead, we're going to have to do it manually. And we'll do that with a transaction because we don't want to find out the correct ID to use and then have the ID change because some other insert happened between them. So we're going to go up here and start our transaction. Now, in a transaction, it's important that everything happens individually. So we're going to add a semicolon to the end, and that says run this and then do the next thing. Now we'll do our select. We'll select ID from name. And we don't need a where because we want the max ID. We'll just put max on this ID. Now we're going to have to do one other thing as well because we need to use this ID in our next statement. We're going to have to assign it to a variable. We'll do that by saying at a colon equals, and that'll allow us to use at a later on in the sequence. So we'll put a semicolon on this one, and now we'll run our insert. Insert into name set ID equal to at a plus 1, because remember we want to auto increment. We already have one max value. Then we'll set first name equal to Oliver and last name equal to Tanel. And then we'll commit this transaction. So if I run this, and then we go back and look at our product table or our name table, we've inserted Oliver Tanel,
and we've auto-incremented the ID by using our transaction. Now, if I were to go back and try to run this again, but instead of committing, I used rollback, you're going to see that it did not insert a new value. That's because the rollback canceled everything that happened before it. It didn't make it permanent. This isn't too common when having to do things interactively like we're doing. However, if you're doing a whole lot of transactions in code, you may need to check that each one is successful before determining whether you want to commit or roll back. And that completes our lesson on MySQL and queries. I hope you enjoyed it. This has been brought to you by CreativeOnlineSchool.com.
Hello and welcome to part 1 of the MongoDB lecture series. In this video, you'll learn a bit about what MongoDB is, how it works, and why you may want to use it for your projects. I'm Ridoy Majumdar, and I'm the instructor for this course. I have many years of programming experience, and I've used MongoDB as a database for many projects in the past. I'm a professional full-stack web developer with experience using technologies such as Node.js, PHP, and of course, Mongo. Here's a brief overview of what you can expect to learn in this course. First, I'll introduce you to MongoDB and the way that it stores data. Then, I'll show you how to install MongoDB on your machine. We'll spend a couple of videos together demonstrating both basic and advanced queries that you can do using MongoDB for handling your data. And in the last few videos, we'll build 2 web projects starting from scratch using Mongo and PHP. So, what is MongoDB? It's a non-relational database software built for agility and scalability. It was started in 2007 and is maintained by MongoDB Inc., which is headquartered in New York City. Many major companies, as shown in this graphic, use MongoDB for their data storage needs. In recent years, it's become a popular database solution because of its speed and ease of use. MongoDB stores data as documents, and it stores these documents in collections. Suppose that you're building an application for tracking the attendance of students in a classroom. For this application, you may decide to create a collection named students, and each document in this students collection can represent the data for a single student. Documents stored in MongoDB are in the JSON format. If you're not familiar with what JSON is, that's fine because it's very easy to understand and it's also very human readable. JSON stands for JavaScript Object Notation. Objects in JSON start and end with curly braces, and data is stored as key value pairs. Here's an example of an object. You can store strings like John Doe, or you can store numbers like 42 without quotation marks. And you can also store arrays, for example, this array of strings right here. You can also store objects within objects. Thank you, and I hope you enjoyed watching this first video in the MongoDB lecture series. In the next video, I'll show you how to install MongoDB on your computer. Welcome to the second part of the MongoDB lecture series. In this video, I'll show you how to get MongoDB set up on your computer so we can start playing around with it. To get started, visit mongodb.com in a browser and click Download in the top right corner. This will bring you to the Downloads page. Click Community Server and select the operating system that you're running and click Download. To save us time, I've already downloaded and extracted the archive from mongodb.com, but while you're waiting for it to download on your end, MongoDB requires us to create a data folder. If you're on OS X, navigate to the / directory and create a new folder called data, all lowercase. Inside of the data folder, make another folder called db, all lowercase. Great. Now let's return to the folder that we just downloaded from mongodb.com. Inside, you'll find a bin folder. Open this folder and you'll find a number of executable files. Before we can use MongoDB, we have to run it locally. To do that, open the MongoD executable. This will open a new terminal window that prints the details of the MongoDB server that is now running. If that went well, then we can return to this folder and open the Mongo executable. This will open a shell that allows you to interact with your database and execute commands. Now we're ready to build a database. Stay tuned for the next video where we'll create our first collection and perform some basic queries to add and modify documents in that collection. Welcome to part 3 of the MongoDB lecture series. In the next couple of videos, we'll be going over some basic and advanced actions that you can perform in the Mongo shell. In this video, we'll be going over how to create documents and how to search documents. Type show DBs once you're in the Mongo shell, and that'll show the databases you have. Type use and database name to either create or use a database if it exists. So now that we're in our database, we can create a collection. To do that, type db.createCollection and the name of the collection you want to create. And now that we have our friends collection, let's insert some documents into it. To do that, use db.friends.insert, and in here you put in a JSON object. So let's make a name property where the value is John and an age property where the value is the number 23. Great. Now, if we do db.friends.find, we'll see the document we've just created. Let's insert a few more documents in here. Let's make a Mary whose age is 25 and a Bob whose age is 24. Now we have all three of our friends. And say we want to narrow down our search. All we have to do is pass in a JSON object into the find function. So say we want to display only the documents that have the name John. Then you would do it like this. Say you want to display or find only the documents where the age is 23. You can do that too. And you could also search for all the documents where the age is greater than 23, for example, using the greater than operator, $GT. So $GT is an example of an operator that you can use. There's a whole lot of them. And I'm not going to go over all of them. So you can find, if you're curious, all of them on docs.mongodb.com. So that's the basic usage of the find function for narrowing down your search. Say that you also want to narrow down the number of fields that are returned. So for example, I want to hide the name field. To do that, you pass in two arguments into the find function. The first is your search term, and the second defines the fields that you want to display. So I want to just display age. And here you see that _ID is still returned. That's because by default you have to explicitly define for MongoDB to hide it. So you set that to 0. I should also mention that _ID is a unique identifier that's automatically inserted into new documents by MongoDB. Say we want to sort our results. Well, we just append a .sort. And we specify that we want to sort in ascending order of age, like that. Or we could use -1 for descending order. Pretty simple. And finally, say that we want to limit the number of results we get back. So if we do an empty find, we get 3 results back. Whoops. But say we only want 1 result, then we would do something like .limit of 1. And we only get 1 document back, or .limit of 2. If we do .limit of 4, we get 3 documents back because the 4 only specifies the maximum number of documents we want back. So that's how to both create and search documents in MongoDB. In the next video, we'll be going over how to update and delete documents. See you next time. Welcome to part 4 of the MongoDB lecture series. In the last video, we went over how to create and search through documents. And in this video, we'll go over how to update and delete documents. To update documents, you would use db.collectionName.update, and the update function takes in 2 arguments, the search term and the new data that you want to add. So for example, if we wanted to add a gender field to all of our existing documents in the friends collection, we would pass in an empty search, and we would use the set operator and define gender to be M for all of our documents. Now you can see that it only modified one of our documents, and that's because by default, update only updates one document at a time. So to ask it to update more documents, you have to set the multi option to true by passing in this third argument. And now it did apply the changes to all the documents. We can also target particular documents. So say that we want to change Mary's gender, set it to female. Then we would do it like this. And say that we wanted to get rid of the gender field for all of our documents, then we would just use the onset operator instead, and we would do an empty search, and we have to make sure that the multi-option is true. And if we want to update a document in its entirety, so in other words, to replace a document, let's say that we want to replace John. Instead of using a set or onset operator, we would just pass in a completely new document here. So let's say that there is a John 2, and he has a favorite food field where it's pizza. So we replace the John document with this new document that we passed in here. So that's how to update documents. Let's go over how to remove documents. Very simply, you just use .remove and you pass in the criteria for the documents that you want to remove. So let's say we want to remove John 2, or all the documents where the name is John 2. It'll happen like that. Say we want to remove all documents, we just pass in empty braces. And so we have no more documents in our collection. And finally, to drop a collection, all you have to do is do the collection name .drop. And we can see that we no longer have our friends collection. So that's how to update and delete documents in MongoDB. Welcome to part 5 of the MongoDB tutorial series. In this video, we'll be going over document relationships. We'll be discussing why relationships are important to consider, and we'll be talking about the 3 different kinds of relationships: one-to-one, one-to-many, and many-to-many. You need to worry about the way that your documents are related and the way that you define those relationships, because if they're defined poorly, then that has a direct impact on the performance of your database. And no one is going to want to use your website, for example, if the data loads slowly. So in order to optimize performance, you need to intelligently plan how you design your database architecture. For example, if you have a website like Amazon.com, there is an optimal way of associating all your products and all your manufacturers so that everything loads quickly. The first kind of relationship to consider is a one-to-one relationship. You don't need to overthink this. It's pretty simple. You just need to have, so for example, if we have a database that has users and home addresses, and each user has one address and each address has just one user, then we can simply define the user object and define the home address object, and in either one of them contain a reference ID to the other. So here in the address, I've defined user ID is Homer, and that links this address to this user. So if I, for example, was looking at this user and I want to find his address, I would do db.addresses.find where user ID is equal to Homer. So that's pretty straightforward, and you don't need to overthink one-to-one relationships. One-to-many relationships can become a little more complicated. Say you have a newspaper website where you have articles and comments. Here's an example of a poorly defined relationship between articles and comments. Here's a whole article object, and it has a comments array. So all the comments on the article are nested inside of the object. So this is fine if you want to load all the comments for an article while you're loading the article. But say you want to upvote any one of these comments. You would have to go through the entire comments array until you find the comment that you want to modify, and then only then could you change this upvotes counter on any one of these nested comment objects. When there's 2 comments, like in this example, it'll work just as fast, but you need to consider scalability. When there's 1,000 comments in this array, it's gonna be a clear bottleneck on your performance. And every single time that a user wants to upvote a comment, you would have to go through this entire array and find the appropriate comment. So this is a bad way of structuring article and comment relationships, or one-to-many relationships. A better way is to do something like this. Define an articles collection and a comments collection. So here's the article on the left. There's no longer a nested comments array, and instead we define the comments as as individual documents in the comments collection. And each comment has a reference to the article. So each comment has an article ID reference that links to the ID of this article. So therefore, if you want to find all the comments, if you're loading this article on a web page and you want to find all the comments along with it, you just need to run a command like db.comments.find, where article ID is equal to article 1. And that would that'll happen at the same speed as loading this. But say that you want to, the reason why this is better is because if you want to upvote any particular comment, you no longer have to traverse through this comments array. You can just specifically refer to any one of these comments and change the upvotes counter. And then there are many-to-many relationships. An example would be comments and tags. You can have a single comment can have many tags, and a single tag can have many comments. So here on the left, we have comments with tag arrays, and these tag arrays contain IDs of the tags that are associated with each comment. And then on the right, we have all these different tags. And so if we want to find all the comments that contain a particular tag, we do something like db.comments.find, where tags contains tag 1. And that would get us what we want. So that's an optimal way of structuring many-to-many relationships in MongoDB. So that's all for relationships in MongoDB. Next up, we'll be talking about indexes. Welcome to part 6 of the MongoDB tutorial series. In this video, we'll be discussing indexing and how that can be used to make your database much faster. Indexes are special data structures that make it easier for MongoDB to fetch records from your database at much quicker speeds. So I made a comments collection, and I've inserted a couple of comments here. And now say that I want to find all of the comments that are written by Homer. I would do a find query like this, where I set author to Homer, and I would execute it, and it would give me the document I want. However, the more comments that I have in my collection over here, the longer this query will take to execute, because in order to find all the documents where the author is Homer, it has to go through the entire collection and check each author field to see if this author is Homer, if this author is Homer, if this author is Homer, and so on, until it gets all the ones where the author is Homer. So the fast way to do it is to create an index. That allows MongoDB to not search through the whole collection, and it can actually instantaneously get all the documents where the author is Homer. So to do that, you set ensure index, and you define an index on a field. So we're going to define it on the author field, and we're going to write 1 to define it in ascending order. So now we have a index on the author field. So if we write get indexes, we'll see the one that we just created, author_1. Also note that there is automatically an ID index by default, and that's the reason why when you're given the ID of an object, you're able to automatically fetch it instead of having to traverse through the entire collection. MongoDB does that by default, and so that's pretty neat. And you can drop an index like so. You use the drop index command, and you put in the name of the index that you want to drop. So we just dropped the author index. Now we can also make indexes on values inside of arrays. So say that we want to make an index on tags, we can do that pretty easily by doing db.comments.ensure index and tags in ascending order. And then all we have to do is db.comments.find tags, and then wherever we search something like this, tags where pizza is contained in the tags, we'll get, for example, these 2 documents where pizza is contained in the tags. And so by creating an index, that operation becomes much faster. And finally, we can make a index on text. So the way that works, say that we want to search through the text of each of these comments. So I want to find all the comments that mention the words MongoDB. Very simply, I can do another ensure index command and write that I want to make an index on the body field, and I define the type as text. Great, now I can do db.comments, or yeah, db.comments.find, where $text operator is equal to $search operator and the text that I want to search. So let's say I want to search for MongoDB. Great, and it gets us what we want. Say I want to search for comment, and it gets me all the comments that contain the word comment. So that's how to use indexes in MongoDB. And in the next video, we will be discussing our first small project, so you can get a hands-on look at how to use MongoDB in your project. Welcome to part 7 of the MongoDB tutorial series. In this video and into the next video, we'll be going over how to build a basic project using PHP and MongoDB. And in this video in particular, we'll be going over some of the setup that we need to do before we can start using MongoDB inside of PHP. So this video assumes that you have at least some familiarity with PHP and using that to write web pages. But if you don't, then this tutorial should still be very easy to follow along if you have any programming experience. So what we're going to end up making is, well, you'll see here that I have the Mongo shell open and I've created a database and a friends collection, which has 5 entries with names and properties and whatnot. And we're going to end up with this table over here, very simple, that prints out all of the data in our database in our friends collection. And hopefully by doing this project, it'll illuminate to you how the database and the front end all connects and all comes together. So the first thing we need to install is the PHP and Mongo driver. And the easiest way to do that on OS X is using Homebrew. If you don't have Homebrew, then it's very easy to install. You just go to brew.sh and you copy this command right here, and that should install Homebrew for you, and it's not much to worry about. And then from there, you have to, once you have Homebrew installed, you can get the PHP MongoDB driver based on the PHP version that you're running. Now, to find out what PHP version you're running, you need to go to your web server. So I'm running an Apache server. So all of my documents are in this directory, and I'm going to make a file called phpinfo.php, type in my password, and you'll simply type phpinfo parentheses and good, and then in a browser visit localhost/phpinfo.php, the file we just created, and it will tell us that I'm running PHP version 7.1. So now that tells us what kind of driver we need to install. So first off, we need to do brew tap homebrew/php. And then once that happens, do brew install PHP 7.1 MongoDB, and that will install the driver that we need. I've already installed it, so it gave me this warning, but it will print out all the it'll print out a lot more when you install it for the first time. So once that's set up, then all you have to do is go back to your project directory. So again, this is where all my server files or all my project files are located. And what we're going to do is we're going to install something called Composer, which is a dependency manager for PHP. If you're familiar with Node.js, it's very similar to NPM. So you want to go to download and follow these instructions and copy these in one by one, each of these commands, and it will set up Composer inside your project for you. And then what you ultimately want to do is, well, you're going to have this composer.far file, and you're going to want to do php composer.fr, which stands for PHP archive, and then require MongoDB/MongoDB. And I've already done that, but when you execute that command, that will bring MongoDB into your project, and you'll have everything you need to get started. In the next video, we'll be going over how to basically take this project now and then now that we have the driver set up, link everything together and print our database contents into this table. Welcome to part 8 of the MongoDB tutorial series. In this video, we're going to take this JSON data, import it into our database, and have it show up in a table on this page. So to do that, you want to pause the video and go to this URL and copy all this data and save it into a .json file. I've done that already, and then you want to use the Mongo import binary and run a command like this. Mongo import, specify that you're using a JSON array, specify your database, specify your collection, and specify the file that you want to import. Run that and it should run successfully. And now we're ready to write some code. So first off, you're going to want to make a file called index.php in your project root. And once you've done that, you need to require the autoload file that Composer creates. And you want to make a new MongoDB client connecting to localhost. You want to make an object that allows you to interact with your collection. So client, arrow, your database name, arrow, your collection name, and then we're going to run an empty find query on the friends collection. And now that we have that, we're going to, the result variable is a 2D array, is a iterator object, and we want to convert that to a nice 2D array. So to do that, we're going to use the iterator to array function that comes built into PHP. And once you have that, let's just print everything out to see what we're working with. And you'll see the five entries that were present in this JSON document. And so this looks good, and we're ready to put this all into a table. So let's make some body tags in the HTML down here. Let's make some table tags. Let's make a T head, which is the head of the table, and a T body, which is the body of a table. In the T head, we're going to make a PHP for each tag that iterates over the keys here. So because we want ID, name, age, and gender in our header, so we're going to for data 0 as key arrow value. And for each, we're going to want to enclose this entire thing inside of a table row tag. And then inside of here, we want th tags. And we want to basically print out our keys. So here you go, that's their table head. We don't want the ID field though, so what we're going to do is we're going to go back up here to our query, and we're going to pass in another array. Or it's going to look something like this, where we specify that ID should be hidden. And once you have that, let's save it, and the ID field is hidden. So now let's work on our T body. Essentially what we want is to make a new row for each entry in our collection. So we're going to iterate over all the data, and each data is an entry or a row. Let's just call it entry, and then we're going to have another for each in here, and for each entry we're going to iterate over each of its properties and print out the value. So I'm going to do something like this. Whoops. I'm going to print out a TD and echo out the value. And there's our entire database, our collection, and all of the data fields associated with it. So that's how to get all of the data from your database onto a short little table. So that was our basic project. In the next video, we'll be going over a more advanced project, how to make a Twitter clone using MongoDB and PHP. Welcome to part 9 of the MongoDB series. We're going to make, in the next couple of videos, a clone of twitter.com. So you can write tweets and look at tweets from other users. And to do that, first you're going to have to make a new database. I called mine TwitterDB, and you're going to have 3 collections in there, following tweets and users. And in this video, we're going to make a login and register page. So to start off, you're going to want something called dbconnect.php. It is a very simple file. All you have to do is require composer's autoload.php, then make a new client, and then make a variable called db that allows you to connect to your database, whatever you named it. Then you're going to want to make a file called index.php. This is going to be the login page. You can pause the video and copy down this HTML. This just makes this form over here. So a form, a login button, and a link to the register page. And I'll show you what PHP we need to write to make this functional. First, you're going to want to write session start because we're going to be using sessions to manage login for our users. You're going to require dbconnect.php as well. Whoops, okay, dbconnect.php. We're going to do a quick check to see if any users are logged in. If they are, then we're just going to redirect them to the home page. And finally, we have a form down here, and the action is index.php. So when a user submits, they're basically sending us a username and password. So we're going to check over here if that is the case. And so basically what I'm writing is if the user sent us a password and a username, and password. Whoops, password. First thing we're going to do is we're going to set some variables to pass in. Password, and we're going to want to hash our password because the passwords that we're storing in our database are not plain text, they're hashed for security purposes, of course. Finally, we're going to ask our database, does an entry exist in the users collection where there is this username and this password? So username and password. Now, if there isn't a result, that means that there isn't a user with his username and password in the database. So let's not do anything. Or we could display an error message, but for now, we'll leave that blank. But if there is a user, then we're going to log that in. So we're going to set the session variable to user to the ID of this user that we just got. So result underscore ID. And then finally, we're going to redirect this user to the home page. So like this. And then we're going to want to make a register.php. So literally the same thing, copy the HTML from this index.php, change the action on the form to register.php, change the value here to sign up, and change the link here to index.php so users can go back to the login page. And the PHP is going to be essentially the same for this register page. All we have to really change is this. So get rid of this if statement. We're going to keep this, we're going to redirect the user to index.php after they send us a username and password. And instead of finding, we're going to do insert one into the database. So this register.php, when this form is submitted, it takes the username, hashes the password, inserts it into our database, and redirects the user to the login page. So let's see if that works. We're going to go here, we're going to make a jack test, and we're going to see if that works and redirects us to home, and it does. So that is how to make a login and register page. In the next video, we'll be working on home.php. Welcome to part 10 of the MongoDB series. In this video, we're continuing with the Twitter clone. We're going to create the home page, and we're going to create a header for it. So this should be pretty simple. All we have to do is, and this is the page that the user is redirected to when they log in. So going to start a session. We're going to require dbconnect.php. Then we're also going to have that same check. So if a user is there, if a user is in the session variable, actually we want to do if the user is not signed in, then we're going to redirect them back to the login page. Finally, we're going to do something like this. We're going to make a variable called user data. And essentially what we're going to do is we're just going to have this variable that contains all of the data for our user that's currently signed in. So we get that ID from the session variable, put a semicolon, looks like we're good to go. Alright, now the HTML here is pretty simple so far. We're going to do a PHP include header.php. We're going to include this on the other pages that we make in future videos. And this is just going to be some easy HTML. A little div with a span that echoes the username, a link to the home page, a link to your user's profile, with which we will get to, and a user list and a logout file. So this is a little sneak preview at the pages we're going to be making in the next couple videos. So if you log in, okay, so we have a syntax error on line 10, probably missing a parentheses. No, I'm missing a semicolon right here. Let's try it again. Alright, so it says welcome John. This is the user that I created, that I signed in as, and you have all these links, and that is how to start off with the home. Welcome to part 10. In this video we're going to create a form for authoring new tweets. So we have this homepage so far that we built in the last video. We're going to make a little form over here that allows us to we make a form right here that allows us to create a new tweet. So down here, just make a new form. Make a field set. Now this form method is post, and the action is home.php, so it reloads the page. Or actually, no, we're going to make a file called create_tweet.php. That's going to send our tweet there. So label for tweet what's happening, like it says on the real Twitter website, as the prompt for a new tweet. We're going to close that out, make a break, and then we're going to make a little text area. Name equals body. Gonna give it 4 rows and 50 columns. And we also want a button. That allows us to send our tweet to the internet. So save that. That's what we're dealing with. So you can write in this box. Great. Now we have to write create_tweet.php. So go to this file, and it's just going to be some PHP. That's pretty straightforward. What we're essentially going to do is we're going to take the variables. So we're going to session start. We're going to require dbconnect.php. Now let's see, if the post variable has the body property, which is the body of our tweet. If it doesn't have that, then we're gonna exit. We're not gonna do anything. But if there is a body defined, we're going to get the user's ID from the session. We're going to get the user's data by asking the database for this user. So find one where the ID is equal to our user ID variable. And our body is the first 140 characters of the post property, the body property in the post variable. And we're also going to create a timestamp. Like this, so we'll be using year, month, date format. Then let's see, hours, seconds, and finally we're going to author this new tweet. We're just going to send it to the tweets collection, insert one. There's going to be a new variable, a new array. For readability, I'll just split it up like this. So let's see. Gonna set an author ID field. We're gonna say author ID is user_ID. We're gonna save the author's name. We're gonna save the body of the tweet. And we're going to save the timestamp. And if that worked, we're just going to redirect the person to home.php. So that should work. Let's see. Tweet. Okay, so we have a syntax error. No semicolon here. Okay, so it looks like it redirected us, so that's a good sign, but we don't see anything. So in the next video, we'll construct a profile page so you can look at the tweets that you've made. Welcome to part 12. In this video, we'll be making a profile page. This will be a general purpose page where an ID is specified in the URL, and we're going to take that ID and show the tweets of the user that that ID corresponds to. So the setup is pretty similar to the other pages that we've made. We're going to start the session. We're going to connect to dbconnect.php. We're going to check if the user is signed in, and if not, redirect them. And we're also going to check if the ID is defined in the URL or not. If it's not defined in the URL, redirect them. And we're going to include the header.php again, and we're going to have this little block of PHP over here. We're going to write a getRecentTweets function that's basically going to print all the tweets of the user whose profile we're looking at. Up here, you're going to have to write some PHP though. We're going to make a user data variable, and that's going to be equivalent to, well, we're going to ask the database to find and give us the data for the currently signed in user. Close that off, and then we're going to get the ID of the profile that we're currently looking at. That would be this. Whoops. Okay, get ID. And then we're going to do the same kind of procedure. We're going to make a profile data variable where the ID is equal to, this is going to get a little funky. This is a new MongoDB \bson object ID. We're going to pass in this profile ID variable that we just made. So the profile data is the data of the user that we just created. or that we're looking at the profile of, and the user data is the data of the user that is signed in. Let's make a get recent tweets function where we pass in a DB. We're going to get the ID of this profile from the URL. And we're going to ask the database to show us all the tweets written by this ID. So author ID equal to this guy. Paste that in. And we're going to want to convert the results from an iterator to an array. So we'll do that like this. And we're going to want to return the recent tweets variable. Let's see what that looks like. Okay, there's a typo, 23, forgot a semicolon. Great, so now we can see the one tweet that John has made. And if we make another one, this is my second tweet. You'll see that it shows up here. So that's good. And in the next video, we'll make the logout page. Welcome to part 13. Very quickly, I wanted to go back to createTweet.php. I forgot to put a $sign in front of this date variable, so you might have caught that and not made the same typo, but in case you did, I just wanted to make that clear. Okay, so let's write logout.php. This is going to be the file that when we click on this link over here, it's going to basically destroy our session and bring us back to the home page. Very simply, start your session. Determine if there is a user signed in or not. So yeah, let's set session user. And so this is checking if there is a user not signed in, then we're just going to go back to the index page anyway. But if there is a user signed in, then we're going to unset the session variable. So basically, yeah, unset the user property of the session variable. We're going to call session unset and session underscore destroy. And finally, we're going to redirect the user back to the home page. And we're going to exit. If I can spell that right. Exit. All right, now let's test it out. If we click log out, great, brings us back. And if we check in here in our session storage, you'll find that there is no session variable here, our user variable. Whereas if we sign in, actually, yeah, never mind. I'm not really sure. But as you can see, the logout works. And that's how to accomplish that in MongoDB and PHP. In the next video, we're going to make a users list and follow some users. And then from there, we're going to create a newsfeed. Welcome to part 14. In this video, we're going to make a user list page, which lists out all the users and allows us to either view their profiles or follow them. So you can go ahead and copy this HTML down here where I include the header and have a div that calls this getUserList function and prints out all the users that are returned, and as well as links to profile.php and follow.php. And the ID for each of these is the specific user. So we're going to write the getUserList function first. It's going to take in a variable called db. And the code in here is very simple. It's just going to be a database request where we ask for all the users. So empty. And users, we're going to basically convert this result from an iterator to an array. Oops, and we're going to pass in the result. And now we're going to return this array of users. And also go back to your home.php. You might remember writing this user data line. We're going to copy it in right here with no changes. And now if we go back to our page, we can see the list of users in the database. Now we have this follow link here. It doesn't do anything yet because we haven't written follow.php, but that's what we're about to do. So the setup is pretty simple, similar to everything else. You start the session, you connect to the database. If there isn't an ID defined, then get out of here. But if there is an ID, then what we can do is put that into the database, in particular into the following collection. So this is going to be a new entry of a user following another user. So the user ID is the ID of the user that is going to be followed, and the follower ID is the ID of the current user. And what we're going to do with this information is we're going to link to our database and the following table, and we're going to insert one new entry. This entry is an array. And this array has two properties. It's got a user, where we're going to insert a new MongoDB bson object ID, which is annoying to write out, but that's how you do it. And then we're going to have a follower as well. Follower ID. Great. So now that we've asserted that to the database, we can redirect the user back to userlist.php. And that looks good. So now if we return back here, say we want to follow Gabby. Now we can't see any of those any of the changes that have occurred. We could visit her profile and look at her tweets, but if we go to our home page, we won't see any of her tweets in our newsfeed, and that's because we haven't written a newsfeed yet. So we're going to do that in the next video. So welcome to part 15 of the MongoDB tutorial series. In this video, we're going to create the newsfeed on our home page. So the very first step is copying this block of HTML. So it's a div. We have this header here saying tweets from people you're following, and this little block of PHP code. We're going to write a function in just a moment called getRecentTweets, and you pass in the database. And we're going to iterate over each of these recent tweets and print out the author name along with the link to their profile, as well as the body of the tweet and the date that it was created. So to write the getRecentTweets function, we're going to do that right now. And after this, we should be pretty much done with our website, so our Twitter clone. So that's pretty exciting, and I hope you're getting a good taste of what development of a full stack web application is like. After I'm done with this, I'll talk about some improvements that you can try on your own as a kind of training exercise. But for now, you're going to get the basically all the objects in the following collection where the follower is equal to the current user. So basically get all the users that the signed in user is following, and we're going to make that into an array like so. And now with this, we're going to make users following into an array. And what we want to do is basically aggregate all the IDs from the result from this database query on line 15. We just want a simple array. Instead of a object, we just want an array with IDs in it. So entry, we're going to get the user property, which is an ID from every entry in the users following array, or in the result array. So now we have users following, which is an array of IDs of user of users that the signed in user is following. And now we're going to do this. We're going to get all of the tweets where the author ID, and we're going to do, because we're trying to query multiple users, we're going to use the in operator. So what I mean by this is we're going to essentially ask MongoDB to look at our users following array and find all the tweets made by any of the IDs in that array. So it looks like we have what we need. And from that, we're going to make a variable called recent tweets, set that to iterator to array of result. Great. And then we're going to return recent tweets. And let's see if that worked. Okay, so we have an error. In needs an array. So I probably made a typo here. Let's reference this. I may have forgotten a parentheses or something. No, it doesn't look like that. It appears that our issue has to do with the way that we're creating our users following array. Oh, okay. So just some PHP syntax. If you're appending to an array, you have to have these brackets over here. So let's try that again. And great. I followed Gabby in a previous video, and her tweets are shown up here. If I go to the users list and say I follow Chris, Chris's tweets show up as well. So that is the how to make the newsfeed. We have our profile, we have our users list, we can follow users, we can author new tweets, and we can log out. In the next video, I will talk about some improvements you can make on this design as a side project so you can enhance your learning and get some more practice. Welcome to the final part of the MongoDB tutorial series. In this video, I'll list out some suggestions for improvements that you can make on this Twitter clone. As you can see, it's pretty simple and bare bones, but there's a whole lot of things you can try to test yourself to see if you've learned anything from this tutorial, and also to practice your own web development skills. So one thing you can try, so I highly recommend spending some time to try improving this design and making your own modifications. But I'll list off some ideas to hopefully inspire you. So one example is this newsfeed. You'll see that the tweets are not in most recent order. So like the most recent tweet is at the bottom here. What you may want to try to do is in your code, when you're making the call to the database, well, you want to look up the PHP Mongo documentation, and you want to figure out how to sort by the date, and then also maybe you want to just get the 10 most recent tweets instead of all of the most recent tweets. So that's one idea for a quick and easy thing to quick and easy improvement to try to make. Also, the website is pretty plain, so you can have a lot of fun doing some CSS styling and making it look pretty. I'm sure that would be a lot of fun. It won't really test your MongoDB knowledge, but it will be a fun web development exercise. And then finally, you can also attempt to make it so that if you have two windows open here, and say I write a tweet in here, and I click tweet here, you can create an auto update feature where once I click tweet here, the tweet will automatically show up in the newsfeed in this other window. So those are a couple of ideas of improvements, and really the sky's the limit. You can do whatever you want with that. And I believe that's the conclusion of this series. That's the end of this advanced project. I hope you learned a lot, and I definitely had a lot of fun making this video series for you. So good luck on the rest of your development journeys, and thank you very much.
Lecture will introduce with Redis. Redis stands for Remote Dictionary Server, and it's released in March 2009. Redis is an in-memory key-value store with persistency. Redis is open source, Redis is written in C, and Redis is the most popular key-value store as per DB Engine. Features of Redis: abstract data types, list sets, stored sets of strings, hashes, and Redis has two kinds of persistence mechanism. One is RDB and another is AOF. I'll discuss regarding RDB and AOF in later slide. Redis has an amazing replication mechanism. The transactions in Redis has the optimistic locking, and Redis is written with Lua scripting language, and Redis has an amazing command line tool. The persistence mechanism of Redis: the RDB, Redis snapshotting, and another is AOF, append only file. The RDB persistence performs point-in-time snapshots of data sets at specified intervals. AOF persistence logs every write operation received by the server that will be played again at the server startup, reconstructing the original dataset. As per DB Engine, the topmost key-valued database is Redis. DB Engine made a cool comparison, cool ranking of key-value stored and other databases, other type of data stores. Here as of December 2017, Redis placed the first rank, then Memcached in second rank, Microsoft Azure Cosmos DB in third position, and also other databases like Oracle NoSQL places number 10th, Oracle Berkeley DB places number 12th, and another cool database, Amazon SimpleDB, places number 15. DB Engine made a cool analysis on Redis. The Redis system properties as per dbengine.com. Redis is in-memory data structure store used as databases, cache, and message broker, and the primary database model of Redis is key-value store, where additional database models available of Redis for document store, graph DBMS, and time series DBMS. I'll discuss in detail regarding these database models in later chapter. Here, DB Engine ranking 123.24 and overall rank is 8, and in number 1 in key-value store rank. Redis initial release was 2009. Redis is licensed under open source, but Redis is not cloud-based. Redis implementation language is C. And Redis supported server operating systems are BSD, Linux, OS X, Mac OS X, and Windows. Redis data scheme is schema-free, and typing is partial. Redis has no XML support, no secondary indexes are supported in Redis, and no SQL is supported in Redis. There are a variety of programming languages available for Redis like C, C++, PHP, Python, etc. And server-side scripting of Redis is Lua, as already said. Redis has no triggering options. Redis replication methods are master-slave replication and master and multi-master replication. Redis has no map reduce operations. Redis consistency concepts are event-driven, eventual consistency. Redis has no foreign keys. And transaction concepts of Redis is optimistic locking, atomic execution, command blocks, and scripts. And Redis has amazing concurrency, durability, and in-memory capabilities. Avalon Consulting LLC made a cool comparison of NoSQL solutions in real-world scenario. They compared with 5 data stores each another, like Aerospike, Redis Labs, Enterprise Cluster, Cassandra Open Source, Cassandra DSC in memory, and Couchbase. Out of them, in application requests per second, Redis does far better than other database schema, other key-value store system, other NoSQL systems. And regarding the application latency issue, Redis also performs the best.